I'll explain you in the last Amma. Rohit, don't worry about that concept. Today we are going to discuss about the losses of prestress. Very, very important, sir. We can expect questions from this chapter very, very much. Sir, see what actually is losses of prestress. What do you mean by losses of prestress? See, when you are doing the tensioning operation for a tendon, when you do the tensioning operation, when you do the tensioning operation, there will be a losses, sir. It can be mechanical loss, it can be different losses are there. Are you getting me? During the tensioning operations, there can be different losses. Are you following, students? So we'll discuss about what are the different types of losses. Any idea, students? Anyone, can you tell me what are the different type of losses which you will observe in, which you will be observing in? Can you tell me any type of losses, sir? Sir, see, we have different losses like elastic shortening of concrete, elastic shortening of concrete, elastic shortening of concrete. Next, shrinkage of concrete, shrinkage. Sir, loss due to elastic shortening of concrete, loss due to shrinkage of concrete, loss due to creep of concrete. I'll individually explain you, Amma. Don't worry about it. One other thing is creep of concrete. Okay. Another one is relaxation of stress in steel. Relaxation of stress in steel. Entendra? Relaxation of stress in. Huh? Pity. Pity. See, students, when I talk about these four losses, sir, these losses are observed in both pre-tensioning. These four losses are observed in both pre-tensioning and post-tensioning. If you see elastic shortening of concrete, relaxation of stress in steel, creep of concrete, all these things are observed in pre-tension and also post-tension. These are observed in pre-tension as well as post-tension. But see, students, we have two losses like frictional loss. Sir, this itself is an important question. Frictional loss. And next one is anchorage slip. Next one is anchorage slip. Frictional loss and another one is what, sir? Anchorage slip. So these two losses are specific to post tension. I'll tell you why these two losses are specific to post tension. These two losses are specific to post tension. They can ask you, frictional loss and anchorage slip is what, sir? Specific to post tensioning. So remember, students, why these two losses are specific to post tensioning. I'll explain you later. So it's a new chapter SKR. Sir, here I would like to tell you, they can ask you in the objective question, which of the following loss is specific to post tension. Remember, frictional loss and anchorage slip are specific to post tension. Okay, students? Now let us discuss about the elastic shortening of concrete. Now let us discuss about the elastic shortening of concrete. Now let us discuss about the elastic shortening of concrete. What do you mean by elastic shortening of concrete? If you talk here, what do you mean by elastic shortening of concrete? Sir, see, the important point I would like to tell you, suppose, see here students, when a pre-stress is applied, 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 shortening of concrete takes place. Sir. When a pre-stress is applied, shortening of concrete, when a pre-stress is applied, shortening of concrete, when a pre-stress is applied, shortening of concrete takes place. What, sir? When a pre-stress is applied, what is happening? Shortening of concrete is takes place. Suppose, see here, I'll tell you. Suppose if you see this is a pre-stress concrete beam, here you will have the here you have the tendon, and this tendon is subjected to what, sir? Here it is subjected to pre-stressed force. Sir, this is like what, sir? Is it not like compression force? So obviously, the beam will or the section will be compressed. So what it will happening here? The shortening of concrete is taking place. Yes or no? So whenever there is a shortening in concrete, this will automatically there will be a shortening in pre-stressing steel also. Sir, if the concrete is pre-stressed, the steel is also getting pre-stressed. Simultaneously, there is a shortening in. Students, is it clear, Amma? Sir, pre-stressing force is something kind of compression force. Due to that compression force, shortening of concrete is happening. Due to shortening of concrete, shortening of steel also will happen. Yes or no, students? Shortening of concrete will also happen. Now, see, students, they can ask you loss due to loss due to loss due to elastic shortening, loss due to or loss of pre-stress, you should write loss of pre-stress due to elastic shortening, sir, is given by the formula. Can anyone tell me is given by the formula? M into Fc. It is loss due to elastic shortening is given by the formula M into Fc. Now see, students, what is M? M is the modular ratio. What is modular ratio, students? It is the ratio of Young's modulus of steel upon Young's modulus of concrete. Modular ratio is nothing but the Young's modulus of steel upon Young's modulus of concrete. So here if I talk here, modular ratio is what, sir? It is the ratio of Young's modulus of steel upon Young's modulus of. So what is Young's modulus of steel again? Sorry, Young's modulus of concrete is how much, sir? Young's modulus of concrete is 5000 root FCK. Now, this is also very important, students. What is FC? FC is nothing but the stress at the level of steel. This is very, very important, sir. What is this meaning? I'll tell you. FC is the stress at the level of steel. What do you mean by stress at the level of steel? See students, if I consider here, if I consider here a section, if I consider here a section, and this is the neutral axis, and here we have the, here we have the, here we have this what sir? This is a tendon. Now he's asking the stress at this level of steel. So this is at a distance of eccentricity. So if you talk about FC, sir, here there is a pre-stressing force. So due to direct force, it is P by A and P by A plus M by Z. Now see, what is P by A? P by A, M is nothing but what sir? Load into eccentricity. Here it is load into eccentricity. Z is what sir? I by Y. But Y is the distance from neutral axis to the extreme fiber is D by 2. But here is asking at the level of steel. He is asking at this point. So here it is I by E. Are you following, sir? Sir, usually what we used to write is I by the overall depth is D. Then you used to write it I by D by 2. But here it is at the level of steel. So we are writing E. So FC is equal to load by area plus P square upon I. So this is known as the stress at the level of steel. Okay. So loss due to pre-stressing loss is given by the formula is M into FC, where M is the modular ratio, FC is the stress at the level of steel. Now another important point. There is no loss due to, there is no loss of, there is no loss of pre-stress, there is no loss of pre-stress in post-tensioning. There is no loss of pre-stress in post-tensioning due to elastic shortening. Sir, the loss due to elastic shortening is not observed in post-tension when all the wires are tensioned at a time. When all the wires are, when all the wires are when all the wires are tensioned at a time. All the wires are tensioned at a. Sir, here what I would like to tell you here is, suppose if you talk about the loss of pre-stress, see, suppose we have in post-tensioning, we used to have this is duct, this is another duct, and this is another. So here if you see, if all the, sir, actually if you tension this, there will be a loss in the this steel bar. If you are tensioning this, there will be a loss in this steel bar. But if all the wires are tensioned at a time, then there is no loss. Clear, students? Backslide, sir. Sir, is the elastic shortening clear, students? Any doubts? So two things you have to remember. Sir, elastic shortening, due to elastic shortening, concrete gets shortening, and due to concrete shortening, steel will also shorten. The elastic shortening is given by the formula M into FC, where M is the modular ratio, FC is the stress at the level of steel. My dear students, again and again I'm telling you, most of the students, they do the mistake taking, yes, FC at the stress at the outermost fiber. But you have to think FC is the stress at the level of steel. And one more thing, that all the wires are stressed. or when the while the steel wires are tensioned at a time, there is no loss due to elastic shock. There is no loss due to when all the steel wires are tensioned at a time, there is no loss due to elastic shortening. Agree, students? Agree? Okay. Now see, students, we'll solve one problem, Amma. We'll solve one problem here. So what is that problem we'll discuss? Okay. The problem. Now see, here the problem here is a rectangular. The problem here is the question here is a rectangular. See, the question here is a rectangular, a rectangular, a rectangular, pre-tensioned, a rectangular, pre-tensioned, a rectangular, pre-tensioned, pre-stressed concrete beam, a rectangular, pre-stressed, pre-tension, pre-stressed concrete beam. So, pre-stressed concrete beam has a straight concentric force, has a straight, has a straight concentric force, has a straight concentric force with a of this is entire is pre-stressing force on 1000 kilonewtons. The beam is the beam is 300 into 500 mm in section. M20 grade is used. What is the loss due to? What is the loss due to? Elastic shortening. Now see, students, when they ask you this problem, when they ask you this problem, here you should understand one more important thing. When they ask you this problem, they have to loss due to elastic shortening. Sir, see, when I talk about the loss due to elastic shortening, here what I would like to tell you is loss due to elastic shortening is given by the formula M into Fc, where M is the modular ratio that is equal to Young's modulus of steel upon Young's modulus of concrete. Okay, what is Young's modulus of steel? It is standard value 2.1 into 10 power 5. If they have not given, you have to take this. And what is Young's modulus of concrete? I told you 5000 root Fc. That is equal to 5000 root 20. Now, what is Fc? What is Fc, sir? Fc is nothing but the stress at the Fc is nothing but the stress at the level of steel. Fc is nothing but what, sir? Stress at the level of steel. If you talk Fc, what is Fc, sir? Fc is nothing but the stress at the level of steel. So here, if I talk stress at the level of steel, you can say P by A because he has told it is a concentric force. When there is a concentric force means eccentricity will be zero. So here the load upon area. So load is 1000 kilonewton. 1000 load upon area is 1000 kilonewton means 1000 into 10 power 3 upon 300 into 500. So this will be 100 by 15. 100 by 15 is nothing but 6.67 Newton per mm square or Newton MPa. And this value does not have any units. Can anyone tell me what is this value, Amma? 2.1 into Sir Simran Nazir, actually this is a concentric force. If you see, I told you in a concentric force, it acts at the center. So there will not be any eccentricity. So eccentricity is zero. So here I would like to tell you, my dear students, the what is this value, sir? Anyone can you tell me 5,000 root 20 is how much? 4.5 4.5 means 22,500 divided by 2.1 into 10 power 5. So this is the performance 0.22. How much, sir? It is how much? Nearly 9.8. 9 point. How much, sir? Can anyone tell me what is the modular ratio value? Can anyone tell me what is, sir? Calculation have you done? Anyone? What is the modular ratio value, sir? 9.39. Thank you, Yatin. So 9.39 or something. So what is the loss is, you can write here 9.39 into 6.67. How much, sir? It will be roughly, sir, whenever, see students, whenever these kind of problems are there, 9.4 into 6.7, what I will do is, I'll add 0.67 here. This is a higher value, right? 10 into 6, it will be roughly around 60, sir. Now please solve what will be the value. Can anyone tell me? What will be the value, sir? It will be around 58 or 59. What is the value, sir? Can anyone tell me? Sir, 9.39 into 6.6. How much, sir? What is the value, students? What is the 59.62.63? Okay, here it is 62.6. Sir, see, I'll tell you one calculations also, Amma. Whenever in a college, means in your exam, they have given some 3.2 into 1.8. Okay. See, 3.2 into 1.8, 3.2 is a higher number. So here you can add 3.2, this point 2 here. 3 into 2, you will get 6. If you see also this, what you will get? This value, if you see, you are adding to a lesser number. So it should be less than 6. You will get something around 5.7 or 5.8. How much you have reduced? Here it is 5.8 if you reduce. This will be equal to how much, sir? 57.6. Are you getting? If you do exactly, it will be 57.6. Are you getting me, sir? Sir, I'm telling you just the calculation. Suppose if you have 7.8 into 9.2. Sir, see, these two you add here, it will be 72. Okay. Now, what I would like to tell you is, if you solve this also, it will be somewhere near 72 only. Are you getting me, sir? Okay. The leave about that, I think it is not. But whenever you don't have calci, sir, you have to think these how these things will be also done. So next one we want to discuss is a next one I would like to discuss here is the loss due to loss due to shrinkage of concrete. Next loss is due to, sir, elastic shortening will occur both in pre-tensioning as well as post-tensioning. Next one we have is the loss due to shrinkage of concrete. Sir, what do you mean by shrinkage, student? Sir,
Backslide,
what
sir.
do you mean by shrinkage, students? Here, see, when you put a
Backslide, sir.
cotton cloth in a water, it will get shrunk. So shrinkage is nothing but volume reduction, students. Shrinkage is nothing but volume reduction. So here you should understand, students, What is shrinkage? Shrinkage is nothing but what, sir? Shrinkage is nothing but the volume reduction. So what is shrinkage if they ask you? First of all, we'll see shrinkage. Shrinkage is defined as the change in volume of the concrete number. Shrinkage is defined as the change in volume of the shrinkage is defined as change in volume of shrinkage is defined as what's the change in volume of the concrete number. Change in volume of the concrete. Sir, volume reduction is nothing but shrinkage. Sir, here the shrinkage depends upon humidity in atmosphere, but it is this point is very important. Shrinkage depends upon humidity in atmosphere, not on the application of load. It depends upon the shrinkage depends upon the humidity in the atmosphere. Shrinkage depends upon the humidity in the atmosphere. Shrinkage depends upon the humidity in the. So humidity depends upon the. Sorry, I would like to tell you loss of shrinkage due. Loss of it depends upon humidity in the atmosphere, but it is independent of. But it is independent. It depends upon the humidity in the atmosphere. It depends upon the humidity in the atmosphere, and it is unrelated to the application of load. And it is unrelated to what, sir? It is unrelated to application of load. So here, see students, when a beam or anything is there, we are habituated of the beam. If the beam shrinks, that is, we think that it is due to application of load. But actually, in ground reality, what I would like to tell you here is, shrink does not depends upon application of load. It does not depends upon what's a application. It depends upon the humidity in the atmosphere. It depends upon what's a it depends upon humidity in the atmosphere, and it is independent of the application of load. It is independent of the application of the load. Now, what factors are affecting shrinkage of concrete? What are the factors affecting shrinkage of concrete is the first one. Which factors are affecting shrinkage of concrete is type of cement, type of cement and aggregate, type of cement and aggregate. And next one we have is the method of curing. Sir, on what factors loss will depend is type of cement and aggregate. And the next one we have is the method of curing. The second one we have is the method of curing. So here what I would like to tell you is when you use high strength concrete, definitely due to low water cement ratio, due to low మాట్లాడు due to low sir what I would like to tell you here is when you are using high strength concrete amma HSC when you are using high strength concrete, what I would like to tell you is when this high strength concrete you are trying to use with low water cement ratio, it will result in the reduction of shrinkage. Sir, shrinkage means simple thing. Amma. You have a cotton cloth, and if you immerse the cotton cloth in a water, there will be a volume reduction. That reduction, what you have observed in concrete, is also nothing but the shrinkage. So, how we are correlating with the pre-stressed concrete? So, when we are thinking here, వినబడట్లేదురా రాము నీది రాము నీది మ్యూట్ 1 second students. Okay, see. So here what I would like to tell you is low water cement will lead to high strength concrete. with low water cement will lead to shrinkage. Okay. Now, what is the formula for loss due to pre-stress due to shrinkage strength? Sir, what is the formula for loss due to shrinkage? This problem is simple. When you talk about the Young's modulus of steel, Young's modulus of steel is defined as stress upon strain. It is defined as stress upon strain. So you can write here the loss of pre-stress due to the loss of pre-stress due to, you can write here, see students, the loss of pre-stress due to shrinkage. Loss of pre-stress due to shrinkage. Of pre-stress due to shrinkage. Loss of pre-stress due to shrinkage is given by the formula. Is given by the formula Young's modulus of steel into ECS. What is this is called? This is known as shrinkage strain. What is stress? Stress can be written as strain into Young's modulus. That's what I've written. ECS is nothing but the shrinkage strain. So this shrinkage strain will depend on different values. Shrinkage strain is equal to 3 into 10 power minus 4. 3 into 10 power minus 4 in case of pretension. This is 3 into 10 power minus 4 in case of pretension. And this is equal to 2 into 10 power minus 4 upon 2 into 10 power minus 4 upon log 10 into t plus 2, log 10 into t plus 2, where t is the age of concrete, where t is the age of concrete, t is the age of concrete in days. So this is the shrinkage strain in case of, this is the formula for shrinkage strain in case of what, sir? In case of post tension. This is the shrinkage in case of what, sir? In case of shrinkage strain in case of what, sir? Hello, Matlad. So see students. So what is shrinkage strain is 3 into 10 power minus 4, and this is equal to 2 into 10 power minus 4 into log 10 plus t by 2. Sir, direct formulas will, direct form, sir, please use bilanguage. ठीक है रोहित, मैं थोड़ा थोड़ा कोशिश कर दिया, ठीक है सर. अगर क्या होता है ना, इधर लॉस ड्यू टू श्रिंकेज, सर श्रिंकेज अप्लाई कर दिया तो क्या होता है ना, उधर वॉल्यूम का कम हो गया. सर इधर वॉल्यूम कम हो गया, श्रिंकेज में क्या क्या मैं डिपेंड कर दिया था, इधर इट डिपेंड्स अपॉन द ह्यूमिडिटी and also it depends upon, it also depends upon the, it is independent of the, means it doesn't depend on application of load. That is what factors affect, means it affects the type of cement and how you are trying to cure your concrete. That is also very important. Okay. Next one I would like to discuss is the creep of concrete. Next one I would like to discuss is the creep of concrete. What do you mean by creep of concrete? What do you mean by creep of concrete? Sir, what is creep? What is creep is? What is creep is? Creep is nothing but the long-term deflection under. Creep is nothing but the long-term deflection under. Creep is nothing but the long-term deflection under constant loads. Creep is nothing but the long-term deflection under Constant loads. What is creep if anyone asks you? Creep is nothing but the long-term deflection under constant loads. And remember, creep is a time-dependent phenomena. Means it depends upon time, sir. Creep depends upon time. Sir, if you see in consolidation in soil, it will suppose if you do consolidation of soil, it will not happen immediately. The consolidation will try to happen. You have to observe that the consolidation will happen after after 50 or 100 years. So here what is creep is, a creep is nothing but a long-term deflection under constant loads, or creep is a time dependent phenomenon, Sir, see the creep here, the value of creep varies with respect to the magnitude of the stress. So due to load, there will be stress induced in the section. So creep also varies with the magnitude of stress. So इधर creep क्या होता है ना, वो stress, अगर stress change कर दिया तो creep भी change कर दिया. स्ट्रेस कैसा चेंज कर दिया, लोड चेंज कर दिया तो स्ट्रेस भी चेंज कर दिया. सर क्रीप ऐसा इमीडिएट नहीं आता, ये थोड़ा टाइम लगेगा और ईयर्स में इट विल कम. सो व्हाट इज ए क्रीप इज, it is a long-term deflection under constant loads. So here, sir, creep of concrete results in loss of steel also. So creep of, when you talk about creep of concrete तो हो गया तो concrete में it is not observed only in concrete but it is also observed in steel. So creep of concrete sees there is a loss in steel also. Okay? Steel. Now see students, loss of prestress, loss of prestress, loss of prestress due to loss of prestress, loss of prestress due to creep of concrete, loss of prestress due to creep of concrete. Is a water bar loss of prestress due to loss of prestress due to loss of prestress due to creep of concrete is given by phi into, formula is phi into m into fc. It is given by the formula phi into m into fc. So here what I would like to do. So what is phi? Phi is nothing but creep coefficient. Phi is nothing but what, sir? Creep coefficient. Okay. What is creep coefficient? Already I told you, sir. Ultimate creep upon phi is nothing but ultimate creep upon elastic creep. You know what is M and Fc? Modular ratio, and Fc is the stress in steel. Now you can write it is also what is MFC, sir? Elastic shortening. So you can write phi into loss due to elastic shortening. You can write phi into loss due to elastic shortening. Yes or no, students? Any doubts in this? Sir, deformation sustained load. Sir, please. Sir, Ramiz Raja agreed total. What do you mean by creep is, creep will always see, you told that is absolutely correct. What I'm trying to say is creep is a long-term deflection under constant loads. Constant loads means the loads will be same over a duration of time. But over the period of time, sir, suppose if you apply a load here, the stress will be something like this. But if you apply a load for this for 20 years, 30 years, there will be a slight change in this stress. That slight change is due to nothing but creep. Okay. So it varies with the magnitude of the stress. stress is not something like only, it does not only changes with respect to load, sir. It also changes with respect to the time of application of load. If the load is applied for longer duration, then also there will be a change. Agree, Ramesh Raja? Did I answer your question? That is a good question, Amma. Actually, students, what he is telling is, sir, you have told that stress is, अगर क्या पूछा था, stress change कर दिया पहले पहले का, but load change है तो stress change कर दिया, मैं ऐसे बोल दिया, but here you are telling creep means constant load ना, तो वो टाइम में stress कैसा change कर दिया, वो ही question रमेश का पूछा था. So here what I would like to tell you is, actually, due to the time of load, how much time it is applied, that is also one of the reason for the stress to change. Okay, now the next point I would like to discuss here is the next point I would like to discuss is the relaxation of relaxation of relaxation of stress in steel. The next point I would like to discuss is the relaxation of stress in steel. It is so here what I would like to tell is relaxation of stress in steel. Sir, see, what is relaxation of stress in steel? The loss, the loss of, the loss of stress in steel, the loss of stress in steel under constant strain, the loss of stress in steel under constant strain, under constant strain at constant temperature. At see, you are talking about under constant strain and at constant temperature. The loss of stress in steel. Sir, it is something like similar to creep of concrete. But you are talking about creep is observed in concrete. But similarly, if you talk creep in steel, something like that, see here, creep means under constant loads. Here it is under constant strain at constant temperature, similar to creep of concrete. Sir, see, the loss due to, are you following, Amma? They can ask you this question, sir. What is relaxation of stress in steel? It is exerted at constant temperature and at constant strain. Now see, in practical, sir, loss of pre-stress due to relaxation of stress, due to relaxation of stress, due to relaxation of stress, due to relaxation of stress in steel. Loss of pre-stress due to, go to this one. Loss of pre-stress due to relaxation of stress in steel. You can observe that. Sir, actually, this depends upon the manufacturing of steel. Suppose if the steel is manufactured by Tata Industry, the loss of pre-stress due to varies. If the steel is due to, if the loss of pre-stress due to relaxation of stress in steel is done by, if the manufacturer is Jindal, that case it also varies. So loss of pre-stress due to relaxation of steel depends upon the manufacturers of steel. It depends on manufacturer of steel. And usually the loss of pre-stress due to relaxation is 2 to 8%. It is how much, sir? It is equal to 2 to 8%. The loss of pre-stress due to relaxation of stress in steel is 2 to 8%. Okay. And how do you measure this relaxation of stress in steel? Are you following, students? Please respond. So how do you measure this is, sir, how do you measure actually the relaxation of stress in steel? This is generally considered at 1,000 hours. If you see the 1,000 hours you will take, 1,000 hours of loading means you will consider a loading of 1,000 hours of loading at a temperature of 27 degrees at room temperature. So what are the values which you have observed for 1,000 hours of loading at 27 degrees you will see. And see, students, here the loss due to pre-stress varies from 2 to T to 2 to 8% of initial stress. 2 to 8% of initial stress. And see, students, if the initial stress is 0.5 Fy, relaxation of stress, loss due to relaxation is given by the formula 0. If it is 0.65 Fy, then it is 35. MPa, all these are loss is MPa, sir. Loss you can write. This is the initial stress you can write. Here is the initial stress. Okay. Here if I take zero point 0.7 Fy, then it is equal to 70 MPa. If I take 0.85 Fy, then it will be equal to 90 MPa. So see, students, if it is less than point 0.5, zero point 0.5 itself it is 0. So it even 0.4 will be also 0. But why he has not taken zero point 0.9 here is because the yield stress, you are taking the design stress up to 0.87. If you are talking zero point 0.9 means it is more than 0.87. That is the reason he has not taken zero point 0.9. So for zero point 0.9 it is, sir, what is this is? These are the losses. If the yield strength, initial stress is 0.5, it is 0. If it is 0.6, 35 MPa, 0.7, 70 MPa, and zero point 0.8, it is 90 MPa. Is this clear, Amma? Is this clear, students? So practically what I would like to tell you is loss of pre-stress due to relaxation of steel is something like creep of concrete. It is like constant temperature at constant strain, and it is practically observed. Loss MLA denotes it. Where's sir MLA? Sir, MPa, sir, this is not a loss MPa, megapascal, that is Newton per mm square. Okay. So loss of pre-stress is generally 2 to 8% amma, and it depends upon the manufacturers. Okay, please go through this slide. I'll be back in 5 minutes amma. Don't go away. We will have much more interesting losses.
0.8 FY को हम 0.87 लेंगे.
Sir, 0.8 Fy is 90 MPa. We will not take up to 0.9 because 0.9 is 0.87 का ज्यादा है. अगर इधर 0.8 तक में बोल दिया, 0.9 कहीं को नहीं बोल दिया is 0.9 Fy is 0.87 का ज्यादा है, इसलिए वो नहीं कंसिडर कर दिया. वो मैक्सिमम वैल्यू 0.87 तक है. Then how can you consider 0.9? समझ में आता?
0.87 equals to 90 loss MPa.
No, 0.8, sir. 0.8.
Oh, okay,
These
sir.
are the values which are approximate values, sir. These are the things. Okay. समझ में आता रोहित?
Yes, sir.
Okay. मैं 5 मिनट में आऊँ. Sir, please be online students. I'll be back in 5 minutes. Now, see students, we'll be going to discuss about the loss of prestress due to elastic shortening. Loss of prestress due to friction. Sorry, sir. Loss of prestress due to friction. అరే వీళ్ళని ఇద్దరిని ఎలా రమ్మను పక్క పక్కన నించోమను లా వాళ్ళు లా తయారైపోయిన తర్వాత రమ్మను అడిగి తీసాను సారీ స్టూడెంట్స్ లాస్ ఆఫ్ ప్రీస్ట్రెస్ డ్యూ టు వాట్ సార్ ఫ్రిక్షన్ now see students why the loss of prestress due to friction is observed in only this loss is observed only in what sir this loss is observed only in post tensioning why it is observed only in post tensioning I'll be discussing this students. See students, here I would like to tell you one important thing. Suppose if I take this as a gutter, you will have a duct, right? This is a duct, and you have a tendon here. Sir, this tendon will be, there will be a friction between this duct. This will be something like this, sir. This whole length, there will be a friction between the tendon and the duct. So that is the reason this is observed only in post tensioning. Are you clear, sir? Sir Rohit, this 2 to 8% is there, no, Amma. This is an approximation, Amma. This is from approximate. They have come up with the different values, different samples and all. This is an approximate value. This is not a mandatory. These are from practical observation. It is 2 to 8%. Okay. So see, sir, actually, if you see, you will be doing jacking. If you see in pre-tensioning, there is a tendon and you will be doing tensioning operation using hydraulic jacks. So in that case also there will be a friction between these two. But this friction is very small compared to this friction. That is the reason this friction is only observed in post tensioning. Are you getting me, sir? You can write that very small frictional losses are observed due to 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 hydraulic jacking. There are small frictional losses due to hydraulic jacking. Hence, this can be ignored. Hence, this can be ignored. But the friction between the tendon, the friction between the tendon and the surrounding material and the surrounding duct or surrounding material is not small. Is not small. The surrounding between the tendon and the surrounding material is not small. Bajaj Finance is not small, and this will be considered as what, sir? Length effect. Sir, entire length we are observing this. This entire length you are observing this, right? Okay, this is called length effect, or you can call it as oval effect, or you can call it as curvature effect. Length effect, oval effect, or you can call it as curvature effect. So all these things you can call it as. Friction between the tendon and the surrounding material is not small. These are called as length effect, oval effect, or it is also called as curvature effect. Now see students, suppose see, are you clear Amma why this loss is observed in post tension? Are you clear? There is a loss due to hydraulic jacking, but the loss due to hydraulic jacking is very small. And this loss, the loss between the duct and the tendon is very large, and that we call it as length effect, oval effect, or curvature effect. Is this clear, my dear students?
सर ये डायग्राम में बताना जो सर डक्ट बनाई थी इसमें फ्रिक्शन का।
सर क्या होता है ना, इधर एक डक्ट है ना सर, इधर एक बार सुनो सर। पोस्ट टेंशन इज यूजफुल फॉर व्हाट सर? इट इज यूजफुल फॉर लॉन्ग स्पैन्स. It is useful for what, sir? Long spans. Like this, you'll be connecting. You'll have duct here, you'll have duct here, and you will be connecting this. In this duct, the surrounding material and this tendon will be in friction. This is what I want to tell you. Clear, my dear students? Can anyone please respond? Sir, see, what is, if someone is asking to repeat this, sir, relaxation of stress in steel occurs at constant strain and at constant temperature. It is something like constant. So it is something like creep, sir. So what here observed is this loss will depends upon manufacturers. Means from manufacturing to manufacturing, this loss will vary because it depends upon the how they are manufacturing. Okay, so Tata will follow one norms, Jindal will follow another norm. So to make it at a different particular time, they have taken 1,000 hours and also at a temperature of 27 degrees centigrade. Okay, now see students, what I would like to tell you here is the pre-stress. Suppose if you have considered a frictional force, the pre-stress at a section pre-stress at a section X is given by the formula P naught into e power minus mu alpha plus kx bar minus mu alpha plus kx bar. Now you can ask me here, what is P naught? P naught is nothing but the initial stress. P naught is nothing but the initial stress. Mu is nothing but the coefficient of friction. What is mu, sir? Coefficient of friction. X bar is the length, of the span or length of the beam. You can say length of span. K is known as the wobbling constant. K is called what, sir? Wobbling constant. K is nothing but the wobbling constant, and this constant varies from standard, sir. It is a value which is varying from 15 into 10 power minus 4 per meter. It is measured per meter, sir, to 15 into 10 power minus 4. Okay, we have alpha. What is alpha, sir? Alpha is nothing but cumulative angle in radians. I will tell you what is cumulative angle in radians. See, students, when I talk about cumulative angle in radians, when I talk about the cumulative angle in radians, what I would like to tell you here is, suppose if you have a pre-stressed beam, sir, see, if there is a this is a neutral, the parabolic tendon is something like this. You will have an angle theta here, and you will have an angle theta. In this case, alpha will be equal to theta plus theta. That will be equal to how much, sir? 2 theta. And some people will also ask me, sir, if it is a parabolic tendon, how do you know this? Sir, the generalized equation of parabola is 4h by L square into L minus x, where x is the distance from the section. Sir, how do you get theta? For small values of tan theta, will be equal to tan theta. You know from mathematics, this will happen for small values. So here what I would like to tell you is d by dx is equal to 4h by L square. Sir, 4h by L square into x into L minus x. X into L minus x. The generalized equation of parabola is x into L minus x. So you can write it as Lx. Lx is L minus 2x. So if at supports x will be 0, so this will be equal to 4h by L. So theta is equal to how much, sir? 4h by L. If it is 2 theta means it will be 8h by L. Sir, this is the value only for parabola. Again, if it changes from profile of the tendon, if the profile of the tendon changes, that value will also be changed. Now see students, here if you want to talk about the loss of prestress, loss of prestress, if you want to talk about the loss of prestress due to friction, loss of prestress due to friction is given by the formula delta P is equal to P naught. What is P naught, sir? Initial stress. P naught into mu alpha plus Kx bar. This is the formula. Delta P is equal to what, sir? P naught into mu alpha plus K into X bar. This is the loss of prestress due to friction. This is the loss of prestress due to friction. Clear? Now see students. Sir, see, this is also another important thing. If cable is tensioned from one end, P naught will be equal to P naught. Means you will take the initial pre-stress as P naught only. If suppose if the cable is tensioned from both the ends, then P naught will be taken as P naught upon 2. Are you getting, sir? If the cable is tensioned from one end and if cable is tensioned from both ends, the initial stresses will change. Sir, this is also very important. Am I clear, my dear students? Okay, let us solve one problem. So the loss, I'll repeat the thing, sir. The loss due to hydraulic shocks is very small. Okay, but the friction between the tendon and the surrounding material is not small. It is due to length effect or wobble effect or curvature effect. Okay. Next, the stress at a section is given by the formula P naught into e power minus mu alpha plus kx bar, where mu is the coefficient of friction, alpha is the cumulative angle in radians, k is the wobbling constant, alpha is the cumulative angle in radians. The loss of pre-stress due to friction is given by P naught into mu alpha plus kx bar. For a parabolic tendon, alpha is equal to 8h by L. If the parabola is tensioned from both the ends, if the parabola is tensioned from both the ends, if the parabola is tensioned from both the ends, then you will take half of the initial pre-stress. Then you will take the value of what, sir? Half of the pre-stress. Any doubts in this, students? Okay. So let us solve one problem, Amma. So let us solve one problem here. The problem here is, sir, see, a rectangular. Sir, and one more thing, loss due to frictional loss is observed only in where, sir? Loss due to friction is observed only in post tension. Now see, a rectangular post tension beam of span is 10 meters, sir, and width is 300 mm. Width of the section is 300 mm. Sorry, this is depth, sir. Depth is 300. Width of the section is 150 mm. Initial stress is that is P naught is 1200 MPa. The cable is at an eccentricity of 50 mm and the cable is parabolic tendon. All the values are given, sir. Coefficient of friction is 0.3. Wobbling constant is 0.0015 per meter. And the cable is tensioned at one end only. Cable is tensioned at one end only. Now let us solve this problem. Loss of pre-stress is given by what's the formula? P naught into mu alpha plus kx bar. Sir, see students, see they are asked percentage loss amount. They asked you percentage loss. So loss of prestress is P naught into mu alpha plus Kx bar. So you can write, sir, what is P naught? 1200 MPa. Is 1200 MPa. So here I can write P naught into mu is how much, sir? Mu is 0.3. Alpha I don't know. Because P naught will be P naught only. It is junction from one end only. Plus K into 0.0015. And what is the length of the span? Length is 10 meters. So into 10 into alpha. Sir, alpha is taken as what, my dear students? I told you for parabolic tendon, alpha is equal to 8h by L. Sir, what is H here? If you see here, H is nothing but the rise of the parabola. That is nothing but here eccentricity. So eccentricity is 8 into 50 mm. And what is the length of the span, students? The length of the span is 10 meter. Simran, are you clear, Amma? Okay. So here the length of the span is 10 meter means 10,000. So this, if you do this, 10,000 divided by 400, 400 divided, it will be equal to 0.04. So here you can write as P naught into 0.3 into 0.4 plus, sorry, 0.04 plus 0.0015 into 10. If you solve this, you will get a value of P naught into 0.012 plus 0.015. That is equal to 0.027 P naught. What is asking percentage loss? What is percentage loss, sir? Delta P upon P into 100. So delta P is how much, sir? 0.027 into P naught divided by P naught into 100. So that will be equal to 2.7 percentile. Any doubts in this problem, students? Any doubts in this problem? बेटे हो रहा है? Okay, next one, we are going to discuss the loss due to anchorage slip. Next one I would like to discuss is the loss due to loss due to anchorage slip. Loss due to the anchorage slip. Sir, what is loss due to anchorage slip? I'll tell you. Suppose, see, sir, if this is a tendon, okay, and this is a duct, this is a tendon. When you are doing the extension, when you are doing the tensioning, sir, if you release the tension, sir, you are trying to pull something. Sir, see, what is the loss due to anchorage slip is when you are trying to pull something, and if you release it, when you are trying to pull something, when you try to release it, there will be a slip. Sir, if a rubber band is stretched, sir, if you slightly leave it, it will be slipped. So that is nothing but the loss due to anchorage slip. Sir, see, how do you find out the loss due to anchorage slip? So in case of tensioning operations, in case of tensioning operation, in case of tensioning operation, case of tensioning operation, when the jack is released, in case of tensioning operation, when jack is released, in case of tensioning operation, when jack is released, a small a small slip is observed between a small slip is observed. See, students, I'll tell you one thing how to calculate this. You know what is Young's modulus, sir? Steel. This is nothing but stress upon strain. Young's modulus of is stress upon strain. That is equal to what, sir? load by area by change in length upon original length. So here you can write change in length is equal to change in length by original length. You can write here. So here he is asking loss of prestress. Delta L by L into ES is nothing but stress. So here you can write loss of prestress. Loss of prestress is given by the formula ES into delta L by L. Now see, what is ES into delta L by L is, sir, delta L by L is nothing but, sir, what is delta L? Slip amount. How much it has slip? L is the total length of the tendon. So you can write loss of prestress due to anchorage slip is given by the formula ES into delta L by L. What is delta L means? The slip. What is L means? Total L. Sir, see, is it clear, students? So let us see one problem, Amma. The problem is a concrete beam of 30-meter span carrying an initial prestress of 1000 MPa and the slip at jack end is 5 mm. Young's modulus of steel is 2.1 into 10 power 5. Calculate the percentage of loss. Jartha. Calculate the percentage of loss due to anchorage slip. Calculate the percentage of loss due to anchorage slip. Calculate the percentage of loss due to anchorage slip. So the percentage of loss due to anchorage slip is given by the formula ES into delta L by L. This formula is given as ES into delta L by L. What is ES? Here it is 2.1 into 10 power 5. Delta L is how much, sir? Change in length. It is how much? Slip. That is 5 mm. That is equal to 5 mm. And length is how much, sir? 30 meter. So it can be written as 30 into 10 power 3. So if you do this, this will be equal to 0.7 means 7, 35 MPa. So the loss of prestress due to anchorage slip is 35 MPa. But he is asking percentage of loss. So percentage loss means loss upon initial prestress into 100. So this will be equal to loss is 35 divided by initial prestress is how much? 1000 MPa. Book chesara 1000 MPa into 100. That is equal to 3.5 percent. That is equal to how much, sir? 3.5%. Clear? Now see, students, what you people will think is, sir, there are more losses in pre-tensioning, post-tensioning. But remember the next point I would like to tell you is losses of pre-tensioning is always, even though there are more loss in post-tensioning, loss of pre-tensioning in general, practically, is always greater than the loss of post-tensioning. Okay, for your idea, I'm giving the average things, Amma. So see, losses due to elastic shortening, loss due to elastic shortening. Next, creep of concrete. If I talk about creep of concrete. Next, if I talk about shrinkage, and if I talk about the relaxation, if I talk about the relaxation, see, students, in case of pre-tensioning, and if I consider in case of pre-tensioning, and if you consider in case of post-tensioning. If you consider one is pre-tensioning and other one is post-tensioning. In pre-tensioning, if you see here, this is equal to 3, 6, 7, 2. And this will be equal to 18. And if you consider post-tensioning, 1, 5, 6, 3. That is equal to 15. So see students, these are the percentage losses, sir. These are the percentage losses you can write. And see, you will have everywhere, if you see the losses everywhere, the losses in pre-tensioning are more when compared to this is 15% and this is 18. So to sir, again, don't ask me, sir, how do you know these values? These are practically observed values. Okay, these are all the practically observed values. Okay. Now, any doubts you can ask me. Any doubts in this losses chapter? Is it clear, sir? Sir, definitely JKSSP, HPSSC, SSC, JE, any exam, definitely there will be a question from this chapter. 100%. If you know the simple concepts, definitely questions can be easily written. Laptop పట్టుకెళ్తానండి యశ్వంత్ గారు ట్రాలీ ఉందాము చూడరా అది పట్టుకెళ్ళి మీ దగ్గర ఉంది కదా ట్రాలీ సార్ ఈజ్ ఇట్ క్లియర్ ఫర్ యూ ఎనీ డౌట్స్ ఇన్ దిస్ సార్ సార్ ఎనీ డౌట్స్ Sir, if you don't have any doubts with this, we are done now. Okay. Rohit, I will be telling you in the next class, sir. I remember breaking of wires. Sir, actually, breaking of wires should not be more than 2.5%. Actually, if the wires are broken, means there is some problem with not only with the tendons, there will be a problem in the tensioning operation also. So there you have to go with proper investigation. This is the things which okay, don't worry, Rohit, I will discuss that in the next session. Okay, sir. With this, I'm done. Okay,
तो
thank you
यानी कि
for it.
जब हम टेंशन में उसको करेंगे, जब हम वायर्स जो हम टेंशन लेके आएंगे उस समय जो है सर ये 2.5% ऑफ वायर्स जो वायर का डाया होगा उसका 2.5%
Sir,
कि जितनी
total
हम
number of wires, sir, it is not. Suppose if you are doing 100 wires at a time, 2.5% means 2.5% of 100 wires. Breaking of wires means if you are doing tensioning of 100 wires, 2.5 wires should not break.
ओके
Clear? Sir,
यस
with this we are done, Amma. I hope everyone is clear and please try to practice this session. Thank you and have a good day. Bye bye.